Hello everyone, my name is Iago and today I'm here to talk about decoupling the state layer with custom hooks. So first, before we start, let's cover some ground basics. What are hooks? In the context of this talk, we'll be referring to hooks as a feature in which a UI library allows you to have a better way to isolate, reuse, and compose stateful logic. So we can think in it as a concept independent of library, where we can handle stateful logic or async logic detached from our components. So that way, it's easier to compose and reuse logic as well to decouple our view from the states, independently of the state management libraries, if there's any being used, and so on. I'm not going to give a whole introduction about hooks, type of hooks, or how to use them with React, Vue, or whatever other library. Just know that React has a very good introduction to hooks, and Vue has a very similar feature called Composition API with a very good introduction as well. And be aware that independent of library you are using, be it Angular or whatever else, it has some feature that matches with hooks. So the techniques here apply as well. Now that we know what are hooks, what are custom hooks? Let's take a look in this example. Here we are using useState from React for having a local state with this component. If we create a new function reusing those hooks from React and export that to our component, that's a custom hook. Okay, now that we have covered some ground, why should you care about using custom hooks to decouple the state layer? Or what does it even mean to have my state layer coupled or not? And first, to answer that, let's talk about what is coupling. In software development or computer programming, coupling is the degree of interdependence between software modules. It was created as a part of software quality metrics to reduce maintenance and modification costs. So it aims to improve readability and maintainability. We can say that if two modules are tightly coupled, they are highly dependent of each other, being very hard to reuse, and there is not a clear path from where the data flows through the code. And yet, if they are loosely coupled to each other, there is a clear separation from where the data flows, and it's much easier to understand and refactor them. So talking about coupling in front-end development nowadays, we can think in it as having two main acting parts or layers. The view or our components, where we handle presentation, so things like semantics, structure, and style. And then there is also the state, where we handle stateful logic, things like async calls, and etc. And even though they seem to be separate things, I'm pretty sure most of you have already seen components handling a lot of logic, which is not totally wrong. But eventually, as we add more and more features to an app, this can get out of hand very fast. And that's exactly what we want to avoid in our apps. We want to separate the state from the view by creating a line between them with custom hooks, so we can let the view handle only presentation stuff and the state handles logic and data, connecting the rest of the app to the UI. That way, we achieve a better composability. So at the end of the day, hooks are just functions, so composing them just works. We have a clear separation of concerns, being able to separate into domain-oriented units, where we have custom hooks to represent portions of your domain. And it's also much easier to test components that are not implementing a lot of logic. So it provides us a good testability as well. Cool, now we know why to use custom hooks to decouple this state. Let's take a step-by-step approach to see how we can make a good separation of hooks and why we should expose it to the component. Okay, first, let's establish here some ground hooks. The first one, custom hooks should obey every other rules dictated by the library you are using. Every library has best practices and rules to use to center certain features, and that applies to hooks as well. So make sure you read that first or use some kind of link plugin to enforce these rules automatically. The consumer of a custom hook should not know if it is using Context API, Redux, Mobex, GraphQL, or whatever else. It only and always should expose an object with functions and data to the UI. The third one, custom hooks should not expose the shape of the state being stored, which means that the functions exposed by a hook that are capable of triggering changes in our state should not be simple setters. They should represent comments from your core domain. The last one, a custom hook should not cover too much state. So if your hook is dealing with a portion too big from the state of your app, it should be broken up into more domain-oriented pieces and should be orthogonal to other hooks as much as possible. Okay, now let's see how to actually cut a line between the state and the view to decouple them. I will use here an imaginary blog application for the rest of the examples. So let's say we have a page for listing articles where we can paginate this list. We should also hand async requests to show some sort of feedback to the user and handle errors as well in case anything goes wrong. So from that, to start off, we can take that we have one custom hook called useArticles that will be responsible for listing and paginating those articles. Cool. Now that we have our first hook defined, it's not really doing anything yet. So what should this hook expose to the view? Let's start by defining its public interface first. You don't have to define the interface first every time you create a custom hook, but it's a good way to understand the process and of designing a custom hook and to get used to this approach. So assuming this is the shape of this state we'll be storing after we fetch this data from an API or whatever the source of the data is, we have an array for keeping all the articles and a key for storing the current page of our pagination. This will be the responsibility of the useArticles hook. And we also have another key for storing the current article, and this one we will not cover right now. But we could use a hook called useCurrentArticle or something like that. Okay, so looking at this shape, we already know what data we want to expose to our hook, an array of articles and the current page number. So we can even map the list key to articles, so it is clear and easier to understand who is using on the UI. So now disregarding any implementation details, that's what we want to expose from the useArticles hook. The consumer shouldn't care if Redux or any other state management library is being used, and it should reflect on the keys of the return object. There's more data we could expose to make things easier for the UI. We can return if it is on the first page or last page, if it is loading, or if there's any error during load time. This could be derived from some metadata that is stored, but we can't expose it to the UI. We can also handle loading an error using a state machine, exposing only booleans to the component. So cool, I think we have all the data we need. So what about actions and functions now? As mentioned before, the actions should not just look like setters. They should be meaningful domain-oriented instructions or commands. So instead of exposing actions like set current or load something or set something, we could have a single action called go to next page that will already change the value of the exposed data, and the UI won't have to handle it. So calling go to next page would increment the current page number by 1, loaded and managing the value of the loading status, and this whole thing would be abstracted by the hook. Okay, I think we are all set with the public interface of our hook, but how do we actually implement it? Since a custom hook is an abstraction, it is important to mention that its internal implementation depends on the UI library and the state management we are using. Here, we are going to follow using React and show how to implement both using Redux and React's context API. You won't get in any details on how to use or deal with them, only how and what to use to make the connection between a Redux store or a context consumer through a hook. So for Redux, we use two hooks from the React Redux library. To access the state from our hooks, they are called useSelector and useDispatch. The useSelector receives a selector function as an argument and returns a portion of the state provided by that function. And the useDispatch will return the dispatch function. It is important to say that your hook should not return the dispatch function because that would couple your hook to the component all over again. So if you need to dispatch actions, you should encapsulate it inside your hook so the UI doesn't need to know that. So now let's see how to actually use that. First, let's import this hook we need and find our useArticles hook, returning the interface we already know. So to start, let's start importing the selector we use from our Redux file. Usually, it's a good idea to keep the custom hook file and the Redux selectors and actions in a place closer to each other, usually in the same folder or something like that. Okay, after importing the selectors, we start to query the data we need from our state, and then we can return what I returned to the interface we designed before. There are some keys that are derived from data on our state. So unless they are simple booleans derived from a single value, we should not implement the logic for computing them directly in the hook. So we delegate to functions that are responsible for dealing with business core rules. For actions, we also import them from some Redux file. We create the dispatch function by calling useDispatch, and we start to define our functions that will return to the hook. We could even optimize this dispatch function by using useCallback from React, but we are not going to cover that here today. And basically, that's pretty much it for implement with Redux. It might look pretty simple, but that's all we need for encapsulating a state coming from a Redux store. And actually, that's the main point. Your custom hooks shouldn't be too complicated or contain much logic. For implementing with Context API, it actually looks pretty similar. First, we move all the state management logic provided by Redux to a custom context provider. And again, we are not going in detail here how to use Context API or to actually implement the logic to fetch or manage the articles pages. Just notice how the context value is exactly equal to an interface returned by the Redux hook we made before. The only difference here is where the data is stored and how we manage. So now we just need to import the use context hook from React. We import our custom articles context that we made before and return the use context directly to our hook. That will expose it to our hook the context value we define in the provider. Now we have exactly the same hook implemented with both Redux and Context API. Notice how we only change the content of the hook without having to worry or refactoring the component. That's because we're creating that line between the state and the view. So the consumer of a hook doesn't care about the change, as long as we keep the same public interface. The advantage of this technique is that if we change our state management library, the only part that needs to change are the custom hooks. All right, now we know everything about custom hooks and how to implement them using two different strategies. The only thing left is how to test the components using those custom hooks. There are two main ways for doing that. And the first one is by mocking the path of those custom hooks. Even though mocking imports is not ideal most of the time, mocking the import for a custom hook inside the file that tests the component is one of the easiest approach. Here is an example using Jest. We use module mocking functions to mock the hook path. Then we can change the hook implementation for force in the case we want to test. The second approach is by mocking the data source of our hooks, like creating a fake context provider or a fake Redux store while handling the tests. This also works very well, but it feels like it couples the components tests too much to our state layer, since we have to mock the technology our hooks are using internally. But here it is. First, we create a fake context provider, returning the data we need for the test. And then for this one, we can use a wrapper function of the React testing library to wrap our component with that fake context. If you're not using a React testing library, you can just wrap your component manually with the fake provider every time you will call the render function to test it. Okay, cool. So just to recap, today we learned what are custom hooks, why we should care about decoupling the state from the view, and how to implement them using both Redux and Context API, and how to test components using custom hooks. Here we have some reference in case you guys want to read it, and the links of the slides will be on the description of the video. So yeah, that's it for today. I hope you guys like it. Thanks so much for watching, and yeah, I see you guys in the next one.